Hi everyone. I hope you are all following the videos which you have posted up till now. Just make sure that in case you are not following any particular video, just go back to the previous video and then uh, come back to the present video. There is a link to all the videos, and if you just started following in middle of the videos, then probably you won't be able to catch up. Today we are going to discuss with constraints and degrees of freedom. Like in the previous class we had discussed regarding Maxwell's distribution curves, and I hope you might have subscribed my channel. In case if you haven't, so just go ahead and subscribe the channel, hit a like button. Now today we are going to understand constraints and degrees of freedom. We all have some constraints and we also have some degree of freedom, everyone, each and every one of us. Initially we'll take an example which is away from physics, and then we'll get back to molecular theories and other aspects. So we all have some degree of freedom, like in a sense, like whoever you are. But if you are a person, and if you are going out for some time, then you have a rule at your home, and saying that you are supposed to be at home at 8 p.m. and this time can change to each and every one of us. At some homes this time may be 11 p.m. as well, and the parents might allow them to stay away at till 11 p.m. as well, and this time might be at 6 p.m. as well, depending upon your homes and your culture, your tradition, all those aspects. So if let's say if the time is say 8 p.m. for your home, then you have a constraint of not going out after 8 p.m. So this is a constraint. And what is the degree of freedom? You have a degree of freedom that you can stay away from home till 8 p.m. So this is a constraint, or rather I would say the degree of freedom on time. Now let's say there is other ways as well on which you can have constraints and degree of freedom, and some people might have it on an area. So probably you can go to your friend's place, or you have a particular area marked. Till that point you can just go without informing anyone at your home. But let's say this is that area, this is your home, this is your college, this is your class, and this is your friend's place. There might be a few friends, and this is that particular area which I have marked around in a shape where you can go without informing. But definitely you won't be traveling from one point to another point without informing at your home. So again you have a constraint of not moving outside this area, and you have a degree of freedom that you can just roam around inside the area. If you wish to go to your friend, your class, your college, you want to eat something, you can go to a hotel, but in that particular area. Okay, so that is basically the constraint on space, or rather degree of freedom on space. Now we can also have degree of freedom considering an ant which is on a thread, and this thread, if you can see, this thread is tightly fixed between two rigid support. And please don't mind the diagram, the drawing of an ant. This is an ant which can move in horizontal direction, but it can move only on the thread. So it has one translational degrees of freedom, degree of freedom. Now that ant, if you just see this ant on a wall, let's say this is particular wall, and on that wall we have released that ant. So this ant can move toward the right, towards the left, towards the up, towards the down. It can move anywhere on the wall. That means it has two translational degrees of freedom, because the motion is translational, going from one point to another point. Same it goes for a mosquito if the mosquito is in a room, it can travel in the x direction, y direction, as well as in the z direction. So I can say it has 3 translational degrees of freedom. So degrees of freedom can be of many types. We'll discuss in very short duration now. But consider this mosquito as a molecule. So if this is a molecule, then the molecule can move in any possible direction. I'll show you how. Okay, so if you can see in the diagram, you can just see there is a container, and in that container you have a molecule which can move in the x direction, y direction, and z direction. So if you see, this molecule can move in all 3 possible directions. So I can say that it has translational degrees of freedom, and it has 3 translational degrees of freedom. And the reason why it is having 3 translational degrees of freedom, because it can move in the x direction, y direction, and z direction. Now there are some molecules which can rotate on their own axis. So let's say this is the molecule which is moving around this axis. So this was that molecule, this is that molecule, this is the bond, and this is the molecule which is moving around this axis. So I can say that the molecule can have rotational degrees of freedom. Now there might be 2 rotational degrees of freedom, or max to max we can have 3 rotational degrees of freedom. Also you should note that translational degrees of freedom is 3. Maximum you have 3 axes, x axis, y axis, and z axis. So you have 3 translational degrees of freedom. Regarding vibrational degrees of freedom, yes, it can have 1 or more than 1. This is pretty in detail. We'll discuss in short interval now. So basically translational degrees of freedom can be maximum of 3, rotational degrees of freedom can be maximum of 3, and vibrational degrees of freedom can be 1 or more than 1 as well. Now in my previous lecture you have seen that the kinetic energy of a molecule is equal to a 3/2 kBt. So this is the kinetic energy of a single molecule. Now this 3/2 kBt, I can just split this 3/2 kBt into 3, that is half kBt, half kBt, and half kBt. And I can say that the molecule may be moving in the x and the y and the z direction. So I can say kinetic energy in x, kinetic energy in y, and kinetic energy in z. So if you just analyze this, the kinetic energy in the x direction corresponds to half kBt, and y will correspond to half kBt, and z is corresponding to half kBt. This implies that half kBt is participating in each degree of freedom, because it was having a degree of freedom in x and y and z as well. So each degree of freedom is bringing half kBt amount of kinetic energy, and this law in physics is called as the law of equipartition of energy, which means that every degree of freedom is bringing in half kBt amount of energy. Now do not get me wrong, it's not about a single molecule. We are talking about average of all the molecules. This kinetic energy, this is basically the average of kinetic energy, and it's not the single value. So what is the conclusion of whatever I have said up till now? It says that 1 degree of freedom is going to bring half times kBt amount of energy. So like if you want to understand the basics of what we are going to discuss today, or in the coming lectures when we discuss about the specific heat capacities of mono and di and polyatomic gases, it's this, that each degree of freedom brings half kBt amount of energy. Okay. So yes, I was just mentioning about vibrational degrees of freedom. Let's discuss this part here. So if you see this vibrational degrees of freedom ka concept, let's say we have a pendulum, and this is the rigid support from which the pendulum is hanging. This is the thread, this is the bob, and this, if I have taken it aside, it will keep on oscillating back and forth, back and forth, and back and forth. So this central position is what is called as the mean position, and this is the position at which the potential energy is 0 and the kinetic energy is maximum. Now how this is going to 0 and how it is maximum, we will be discussing that in a chapter called as oscillation very soon. and this position is what is called as the positive extreme because it's on the positive side, and it's an extreme position because the pendulum is not going above this, it's just turning it around here like this, it's just going back and forth like this. At this point the potential energy is maximum and the kinetic energy is zero, and you can understand because at this point the bob actually stops momentarily, and if the velocity is zero, I can say that the kinetic energy is also zero. So at this point the kinetic energy is zero. However, when it returns back, it goes to the negative extreme, and at the negative extreme, this is a negative extreme because it's on the negative side and it's an extreme position, the bob is not going, it's just turning around this position. Here also the potential energy is maximum and the kinetic energy is zero because the bob is stopping momentarily. So this is what a vibratory motion or oscillatory motion looks like. Now when we consider let's say we are considering an atom of okay, so we are considering an atom, let's say this is one atom and this is a bond representing a bond, and this is another atom, and we have a bond in between, and the between bonds it's there is no spring, there is no spring at all, but it acts like a spring model. So this atom keeps on vibrating like this, and this atom keeps on vibrating like this, so it shows a vibratory motion in between them. So now because this bob is this atom and this atom is going to vibrate in this particular plane in such a manner, we can say there is one vibrational mode. Now this is called as one vibrational mode because there is a single spring. Now as we have understood from this pendulum example, from this pendulum's example, that in a vibratory motion we always have a kinetic and a potential energy term both. We have both the kinetic as well as potential energy. So if the pendulum was somewhere around here, it was having some kinetic energy, some potential energy at this point, at this point, at this point. Everywhere it was having some or the other kinetic and some or the other potential energy. So in a vibratory motion you always have a kinetic and a potential energy term. So one vibrational mode brings in 2 times half kBt. So as we have discussed here, 1 degree of freedom brings half kBt. Yes, this is true for translational and rotational degrees of freedom. However, when the body is oscillating, like in this case, one vibrational mode will bring 2 times half kBt because there is a potential energy term as well. However, when the body is moving just from one point to another point, like in this case, its potential energy does not change when it moves continuously, keeps on moving from one point to another point. Also, neither will the rotational, won't be any rotational potential energy. So whatever terms are there is because of the kinetic energy in translational and rotational. However, when we come to vibrational degrees of freedom, you will always have at least one vibrational mode in case if the atom has in case the molecule has 2 atoms. So if there is a 2 atom molecule like this, so it will have one vibrational mode, and one vibrational mode will bring half kBt for kinetic energy and half kBt for potential energy. So this is all about the degrees of freedom and constraints, degrees of freedom, and vibrational degrees of freedom. More on this when we discuss about the monoatomic gases, the specific heat capacity of monoatomic gases, monoatomic, diatomic, and polyatomic gases. So let's be positive on in the coming videos we'll be discussing all this, finding out the ratio of specific heats for all these kinds of gases. I hope you have understood this video. In case you haven't, just go back and listen to the video again. In case if you have any doubts, you can just put it in the comment section and I'll make sure that you get an answer to that. Thank you so much. Please subscribe to the channel. Thanks. Bye.